Dear children, in this session we will learn how to apply laws of exponent to determine the given expression or to simplify it. Now over here it is to determine which of the two given terms are larger. Now if you see, they both have got different nature. One has got exponent 1 by 2, another has got exponent 1 by 3. So their exponents are differing. They cannot be compared. So we will first convert them into the form which can be compared, and then we are going to check which one is larger. So simplifying both of them first, square root of 3 can be written as 3 with exponent 1 by 2. In the same manner, cube root of 6 can be written as 6 with exponent 1 by 3. Now LCM of 2 and 3 is 6. So let us try to convert their exponents same. Let us convert them into same number. So in order to convert this 2 into 6, we multiply the exponent with 3 and we divide it by 3. So square root of 3 can be written as 3 with the exponent 3 by 6. Now this cube of 3 can also be written as 27 with an exponent 1 by 6. So square root of 3 is now reduced to sixth root of 27. Okay, now in the same manner, we'll convert cube root of 6. Now we need to convert this 3 into 6. For that, we will multiply the numerator and the denominator by 2. So we can write it as square of 2 with an exponent 1 over 6. Now square of 2 is 36. So it is sixth root of 36. So you can very well see as 36 with an exponent 1 by 6 is greater than 27 with an exponent 1 by 6. Therefore, we can say cube root of 6 is greater than square root of 3. So in order to make them comparable, we need to see that their exponents are same. Now applying the same in the next one, this is square root of 5 and this is fifth root of 5. So let us first see what will be the LCM of 2 and 5. Now LCM of 2 and 5 will be 10. So we'll convert them into the form which will reflect their 10th root. Now square root of 5, which can also be written as 5 with exponent 1 by 2. So converting the exponent into 1 over 10. Now for that we need to multiply this with 5 and divide it by 5. So we can write it as 5 with an exponent 5 and whole can be raised to the power 1 by 10. So this is same as square root of 5. Now let us simplify this. 5 with an exponent 5. Now if 5 be multiplied 4 times, we get 625. So multiplying it further with 5 and checking what the product will be. So it reduces to 5 into 5, 25 we get. With 5 into 2 it is 10. Adding 2 it will be 12. Then with 6 it is 30 and 1 31. So 3125 with an exponent 1 by 10. So done with square root of 5. Now moving on to the fifth root of 5, which can be written as 5 with an exponent 1 by 5. Now convert this into 10th root of the number which will be obtained here. Now for that we can multiply the exponent with 2. We can divide it by 2. So we get 10th root of 25 here. Now see, square root of 5 as well as fifth root of 5. They both are converted into the form which can be compared. So if you look at both the things, you will find 3125 raised to the power 1 by 10 is greater than 25 raised to the power 1 by 10. So we can easily tell square root of 5 is greater than fifth root of 5. So whenever comparison is to be done, please ensure they have same exponent. If it is not same, then convert them into the form where their exponents will be same so that the basis can be compared. Let us check another one. Now over here we have to evaluate these two expressions. So we are going to simplify them and see what we get. This is cube root of the entire expression. So let us rewrite it. Cube root means the exponent will be 1 by 3. Then we also see that 16 can be written as 2 with an exponent 4. So replacing 16 by 2 with an exponent 4, and it is also raised to the power 3 by 4. In the same way, converting 125. 125 is 5 with an exponent 3, and then it is raised to the power minus 2. Now let us simplify this. Over here 4 and 4 can be cancelled out. We are left with 2 with an exponent minus 3, and here it is reduced to 5 with an exponent which can be written as 3 into minus 2. Let us keep it like this for time being and see if both the terms have got certain power which is common to both. Before that, even this can be slightly changed. We can write it as 1 over 2 whole cube, and doing the same sort of change here, firstly we can write it as 5 with an exponent minus 2 and this raised to the power 3, and then taking its cube root. So you will quickly see 1 by 2 has got exponent 3, 5 to the power minus 2 is also having exponent 3. So because their exponents are identical, we can collectively write them as 1 by 2 into 5 with exponent minus 2 can be written as 1 over 5 whole square, or you can write it as 1 over 25. Now this is the common power they are having, that is 3, which multiplies with 1 by 3. So 3 and 3 gets cancelled out. So what is this reduced to? 1 by 2 into 1 over 25, that is 1 over 50. So the given expression in the simplified form is 1 over 50. Let us check the next one. See this, it is 27 with an exponent minus 2 by 3. Now 27 can be written as cube of 3, and this is having exponent minus 2 by 3. Now this further gets divided by 16 with an exponent 1 by 4. 16 can be written as 2 with exponent 4, and this raised to the power 1 by 4. So if you look at both these, over here 3 and 3 gets cancelled out, here 4 and 4 gets cancelled out. So we are left with 3 with an exponent minus 2 divided by 2. Now 3 with an exponent minus 2 can be written as 1 over square of 3. This is getting divided by 2. Now 1 over square of 3 is 1 over 9. Converting it into multiplication, we are going to take reciprocal of 2. Either we can say this is divided by 2, or we can say this is multiplied by 1 over 2. So you can see after simplifying it, it reduces to 1 over 18. Now taking some more examples on simplification. Have a look at this. You will see there are 4 terms involved here, 2 in the numerator, 2 in the denominator. They all have got common basis, that is 11. So we will see from the numerator and from the denominator how much maximum can be taken common. Now look at the first term in the numerator. It is 11 with an exponent n plus 1. So I will break the exponent as n minus 1 and then plus 2, because 2 minus 1 will give us plus 1 only, keeping the next term as it is, 11 with an exponent n minus 1. Then coming to the denominator, this is 11 with an exponent n minus 1. Second one we will change the exponent part. It is n minus 2. N minus 2 can be written as n minus 1 and then minus 1. Let us rewrite these terms. Now because 11 has got exponent which is sum of 2 terms, so we can even write it as 11 with an exponent n minus 1 multiplied with 11 with an exponent 2, keeping the next part as it is, which is 11 with an exponent n minus 1. Now rewriting the denominator, first term as it is, and breaking the second term into two parts. 11 with the exponent n minus 1 multiplied with 11 with exponent minus 1. This we can do because we know when two numbers are getting multiplied and their bases are same, their exponents will get added. So this will result into the previous term only. Now you look at the numerator and denominator carefully. You will find 11 with exponent n minus 1 can be taken common in the numerator. And what are we left with? This is square of 11. Square of 11 is 121. And from here only 1 is left. Now checking the denominator. In the denominator also 11 with an exponent n minus 1 can be taken common. So here I am left with only 1. In the later part, it is 11 with an exponent minus 1. So we can even write it as 1 over 11. So what do we find? These two terms are getting cancelled out. Rest all we need to simplify. 121 minus 1 will be 120. Let us solve the denominator. When we will solve it after taking LCM, it comes out to be 10 over 11. So converting division into multiplication will take reciprocal of the denominator. So we get 11 over 10. So you can see with 10, 120 can be cancelled out and we are left with 12. So the result will be product of 12 and 11, which we can quickly solve. 11 into 2 is 22, so we have 2 as carry, and 11 plus 2, it comes out to be 13. So in simplified form, the given expression is equal to 132. Now let us try to simplify the next one. We will look at all the bases. Are they in the smallest form or not? If not, then we are going to convert them. You can see here, first term in the numerator, it is product of 3 and 27 with an exponent 3x with an exponent x plus 1. Now this 27 can be written as cube of 3. And this is raised to the power x plus 1. Now same we can do here. This 27 can be written as 3 with exponent 3. And this is multiplying with 3 with exponent 3x. Let us convert some of the parts in the denominator also. So this is 3 into 3 with exponent 3x plus 2. So no change in this part. In the next part we have 1 over 3 multiplied with 27 with exponent x plus 1. So I will write 27 as cube of 3 and its exponent is x plus 1. After doing bit of simplification, we will see if there is scope for taking anything common from the numerator and denominator or not. Now this 3 gets multiplied with x plus 1. So the exponent of this 3 is 3x plus 3. Now moving on to the next part in the numerator, you can see these two numbers are getting multiplied with the same base. They have common base 3. So I can add their exponents. So if I add their exponent, it will become 3 plus 3x, which is same as this exponent. Now moving on to the denominator, here again two numbers with same base are getting multiplied. So you can add their exponent. Over here the exponent of 3 is 1. So if I add the exponents of both these, the resulting term will be 3 with exponent 3x plus 3. In the later part, we'll keep 1 by 3 as it is and we'll simplify this. You can see 3 will multiply with x plus 1. So we are again getting 3 with exponent 3x plus 3. Now you look at the numerator and denominator carefully. You will see from the numerator we can take 3 with exponent 3x plus 3 common. So from the first part 3 is left, from the later part 1. In the denominator, if we take 3 with exponent 3x plus 3 common, in the first part we are left with only 1, but in the later part it is 1 by 3. So you can very well see these two are identical terms, so they can be cancelled out. And what are we left with? We have 4 in the numerator, and if we simplify the denominator after taking LCM, you will find it is 2 over 3. So 4 is getting divided by 2 over 3. We can write it as 4 multiplied by 3 by 2. So this 4 gets cancelled out with 2 and the resulting product comes out to be 6. So you can see we have to convert each of them into as simplest form as possible to get the most simplified value for the given expression. Now taking another example of the same sort, here 4 different terms are getting multiplied. In some of the cases, the bases cannot be further factorized into prime factors, but in other cases it can be done. 3 is already a prime number, 5 is a prime number, 10 can be written as 2 into 5, 14 can be written as 2 into 7, this 6 can be written as 3 into 2, 12 can be written as 2 into 2 into 3, 15 can be written as 3 into 5. So let us first break them into simplest form and then see what do we get. So this is 3 with exponent 2m plus 3n. This we are keeping as it is, multiplied with 5 with an exponent m minus 1. Now 10 can be written as 2 into 5. So this term is 2 into 5 with exponent 2n plus 1. This is how. 2 into 5 with exponent 2n plus 1. So we can write this exponent separately for 2 as well as 5. So we can write it as 2 with exponent 2n plus 1 into 5 with exponent 2n plus 1. So breaking it in that form, we get 2 with exponent 2n plus 1 into 5 with exponent 2n plus 1. So applying the same thing in the next part, 14 can be written as 2 into 7. So breaking it into two parts, that is 2 into 7, and writing the exponent for both of them separately, we get 2 with exponent m plus 1 into 7 with exponent m plus 1. Now doing the same in the denominator, 6 we will write as 2 into 3. So this is 2 with exponent m minus 2 into 3 with exponent m minus 2. 7 we can write 7 with exponent m plus 1 because 7 is already a prime number. We cannot factorize it further. But when we come to 12, you will see 12 can be written as 2 into 2 into 3. So we will be able to write it as 2 with exponent n plus 2, then again 2 with exponent n plus 2, and then 3 with exponent n plus 2. Now coming to the last part, this is 15. We can write it as 3 with exponent m plus 2n multiplied with 5 with exponent m plus 2n. So now if you look at all the bases, they are in the simplest form. They are the prime numbers, cannot be further factorized. So you just now see in the numerator, if there are two terms with the same base, you can add their exponent. So you can see there is only one term with the base 3. So we will write it as it is. But when we move to the next term, you will find there are two numbers with the same base 5 and they are getting multiplied. So their exponents can be added. Let us see what we get. It is m, then minus 1, then plus 2n and plus 1. So minus 1 and plus 1 will get cancelled out. That means we are left with m plus 2n. Now move on to the next term. It is 2 with a given exponent, and you will find there is another term with a base 2 which is getting multiplied here. So in both these terms, the exponents can be added. So we have 2 with exponent 2n, and from here we will get plus m, and this 1 plus 1 will reduce to 2. So done with 3 terms. Now we are left with 7 as a base. So 7 is having exponent m plus 1. So you can see the numerator is all simplified. Let us simplify the denominator. So the first term is having base 2. So you identify how many terms are having base 2 which are getting multiplied. So you can locate there are 3 numbers with base 2 which are getting multiplied. So they can be collectively written as 2 with a base with their exponents getting added. You will see m minus 2 and then it is n plus 2. So this minus 2 and plus 2 gets cancelled out. So what do we have? M, this minus 2 is already cancelled out. Then we have n plus n which will become 2n, and then there is one more 2. So this is the exponent of 2. Then let us see how many numbers have got base 3. So 1, 2, 3. Three numbers are having base 3. So they can be collectively written as single number with a base 3 and the exponents get added. So let us add their exponents. So first one is having exponent m minus 2. To this we will add n plus 2. Now see again, m minus 2 and n plus 2. So minus 2 and plus 2 will get cancelled out here also. Fine. So it is m plus n. And then again one more m is getting added. So it becomes 2m. So already 1n is here and 2n are getting added. So this becomes 3n. So done with the number with base 3. Now moving on to the next one with base 7. There is only one number with base 7 and its exponent is m plus 1. Then in the end we are left with the base number with base 5. This is also occurring only once. So its exponent is m plus 2n. Now you look at all the terms which are getting multiplied in the numerator and those getting multiplied in the denominator. You will find each of them are getting cancelled out. See this? 2 has got exponent m plus 2n plus 2. That is what we are getting here also, m plus 2n plus 2. So they both get cancelled out. 7 with exponent m plus 1, 5 with exponent m plus 2n, and then 3 with exponent 2m plus 3n. So this also gets cancelled out. That means in simplified form, the given expression is equal to 1. Now taking another one, this is an easy one if you see very clearly. Over here it is 4x square with the power 3. So 4 can be written in simplest form as square of 2. So I will first write it as square of 2 and this is square of x whole cube. In the denominator it is 2x cube whole square. So for time being I am writing it like this only, 2x cube whole square. Now to this we are adding the next part. In the next part this is 6 here. 6 can be written as 2 into 3 and then we have got x cube whole raised to the power 2. Denominator is already in the simplified form, 3x square with an exponent 3, entire term with an exponent 3. Now let us distribute the exponent with each term. So this is square of 2 whole raised to the power 3. So this becomes 2 with exponent 6. This is x square with further raised to the power 3. So this also becomes x to the power 6. In the denominator this will reduce to square of 2. This will become x to the power 6. In the later part we get square of 2 into square of 3 and x cube whole square, that means x to the power 6. In the denominator this will be cube of 3 and then x square whole cube, that means x to the power 6. So x to the power 6 everywhere is getting cancelled out. In this term you will see square of 2 also gets cancelled out. So in the first part we are only left with 2 with exponent 4. In the later part with 3 square in the denominator gets cancelled out. So we are left with 4 over 3. Now 2 with exponent 4 is 16. This gets added to 4 by 3. So take LCM and solve it. 16 into 3 is 48. 48 plus 4 is 52. So this is 52 over 3. So this is the solution in simplified form. So you can see how laws of exponents or indices makes the calculation or simplification so convenient.